compute the area of the region bounded by the curves y square equals x, which is x equals y squared, and y equals 2 minus x. Let's graph these two graphs, not necessarily functions. So let me graph over here. X equals y squared. Okay, y equals x squared would be this parabola, but x equals y squared will be here. Okay, that's x equals y squared, or y squared equals x. Okay, and y equals 2 minus x. So y equals 2 minus x, it will be just like this. This is y equals 2 minus x. Okay, and we are interested in finding the area between these two curves, which is this area. Okay, in the previous questions we found this area by the definite integral of upper curve minus lower curve from there to there, but in this question the upper curve and lower curve is the same, x equals y squared. So the method we used does not work. Okay, if we just say upper curve minus lower curve, if the method still works, but we need to look at in different way. So if you look from this direction, just move your paper and look from this direction, you will see this one is upper curve and this one is lower curve. And if we integrate from here to this point of intersection here, then we get this area. So upper curve minus lower curve and going from smaller to bigger, so there to there will give this whole area. So when we are looking from this direction, that means we need to do the definite integral in terms of the variable y. So we need to convert the function as x equals the graph is x equals some function of y. Same thing here, x equals some function of y. And in fact y equals 2 minus x, we can solve for x equals, so which is same as, this one is same as x equals, move x to the left, x equals 2 minus y. So this line is same as x, this is same as x equals 2 minus y. And y square equals x, which is x equals y square. Now we are trying to do the integration in terms of the variable y. So upper curve is 2 minus y. Okay, 2 minus y, and lower curve is y squared. So upper curve minus lower curve. Now we have to go from smaller to bigger, so we need to find these two points of intersections. Okay, for that we set these two curves equal. So x equals y squared, so y squared equals 2 minus y. In fact, we want to find the y values, right? So let's solve this equation. Move everything to the left. Y squared plus y minus 2 equals 0. Factor y plus 2, y minus 1 equals 0. So we get y equals negative 2, 1. So this should be negative 2 and this should be 1. Okay, then now this shaded area, this area is going in terms of y, so it will be dy, and we are writing y equals lower limit negative 2 to upper limit 1, and upper curve in terms of y, which is 2 minus y, minus lower curve, which is y squared. Okay, in fact we could have found this area using x, but then we need to divide this area into several pieces. Okay, not convenient. This is more convenient to do in this way. Let's find the antiderivative of 2 with respect to y, is 2y minus it's like treat like everything as x now, because y is now a dummy variable, so it doesn't, the value of this area does not matter on x or y. So y is y square over 2 minus y square y3 over 3. Okay, once you set up this integral, then just use your calculus 1 knowledge, and we have to evaluate from -2 to 1. Okay, plug in 1 as upper limit minus -2, plug in 1, so 2 times 1 2 minus 1 square 1/2 minus 1 cube 1/3, that's upper limit part, minus lower limit, plug in -2, 2 times -2 -4 minus -2 square 4 over 2 is 2, this minus 2 minus -2 cubed -8/3 negative, and this minus, so positive 8/3. Okay, let me get rid of this parenthesis. It's 2 minus, you can combine, but let me do it this way, 2 minus 1/2 minus 1/3 negative, -4 minus 2, this is -6, and minus -6 plus 6 minus plus minus 8/3. 2 plus 6 8, -1/3 minus 8/3, both negative, so 1/3 -8/3 -1/3 -9/3, which is -3, and minus 1/2, 8 minus 3 5 minus 1/2 4.5, 4 and half, which is 9 halves or 4.5 square units.